Okay, with problem 2, what is the units digit of 33 to the 408th power? Well, you should note that if we were to use our graphing calculator to try to evaluate 33 to the 408th power, we would get an overflow error, which means that the calculator is not able to handle that large of a number. So instead, we'd have to use a different strategy. And one strategy might be to look for a pattern in the units digit as we go up. So instead of doing 33 to the 408th power, I might do 33 to the first power. And I could even start from 33 to the 0 power. With 33 to the first power, I get 33. Now obviously everybody knows 33 to the 0 power would be 1, and 33 to the first power would be 33. So those really you don't need the calculator for. But I'm going to make a table over here on the left. And since we're only looking for the units digit, I'm not going to care what happens before that in the number. So I'm now going to do 33 to the second power. And that gives me 1089. When I do 33 to the third power, I got 35,937, so 7 was the units digit there. Then 33 to the fourth power gave me 1185,921. Now it appears that we have the pattern 13971. We would guess that when we go to the fifth power, we should get something that ends in 3. And in fact, we do. And so we're pretty sure that we have this pattern 139713, etc. If I could, I might try one more. And in fact, 33 to the sixth power does give me something ending with a 9. You should note that when we go to 33 to the seventh power, we no longer have the units digit available. So we can't really do any more than that. We're going to have to make a guess based on what we see that there is a pattern 1397, 1397, etc. So I'm going to put away the calculator at this point. It really doesn't help me anymore. Now with these types of problems, I should note how many numbers are in this rotating cycle. And there are 4 numbers, the 1, 3, 9, and 7. 1, 3, 9, and 7. So if I were to continue my table, it might look something like, and you can see then that every 4 numbers, every 4 integers, the pattern repeats itself, 1397, 1397, etc. So what we really want to do is find out with 408 how many repeating or how many repetitions of that 4 number sequence have occurred. And we do that by dividing 408 by 4. And we would be looking for the remainder there. So 408 divided by 4 happens to be 102. And it divides it evenly. So that means that 408 is a multiple of 4. And if we looked in our table for all the multiples of 4, and 0 is a multiple of 4, 0 is just 0 times 4, 4 is 1 times 4, 8 is 2 times 4. And you should see that for any multiples of 4, the table tells us that the units digit is always 1. And since this number 408 is a perfect multiple of 4, then we would say that the answer is A. Now, of course, it could have asked a different question. It could have asked it for 409 or 410 or any other number. And what we would do then is find out if we know that there are 4 numbers in the repeating pattern, then we're going to divide the number by 4, whatever that number was, and look for the remainder. When the number is evenly divisible by 4, it's going to be one of those multiples of 4, which are always 1. If it were one more than a multiple of 4, meaning if it had a remainder of 1, then the answer would be 3. If it had a remainder of 2, then the answer would be 9. If it had a remainder of 3, then the answer would be 7. And after that point, it would have a remainder of 0 because it would divide evenly. So you can see from this table then that any number that divisible by 4 had a remainder of 1 would be answer would be 3, with a remainder of 2 would be 9, and with a remainder of 3 would be 7. And so that's how we would go about solving this problem or similar ones.